So the formula for percent error is actual minus predicted. So percent error is actual minus predicted divided by predicted. So your predicted yield is always on your bottom because it's what you're comparing it to, right? The only difference is with percent error is you minus the actual from the predicted. Or minus predicted from the actual. And they're absolute values, so if you get a negative answer, just make it a positive. It's an absolute value formula, okay? Okay, so let's do this example. Calculate the percent error and the percent yield for the following. So say this, there's an experiment and the predicted mass that they had was 6.2, but the actual mass of what they got was 7.12 grams. So percent error is 7.12 minus 6.20 divided by 6.20 times by 100. .8%. So now we can do the percent yield. So 7.12 divided by 6.2 times that by 100. Your percent yield is 115. So percent yield, it makes sense if you can have more than 100%, so it's like you got more than what you planted, right? So it seems theoretically perhaps impossible, but but you could have, but that could be a source of error then too, right? Because it's like, well, if it's more than 100%, then that's not totally right either. Because so there might be impurities in it that weigh more. So you're actually weighing impurities in your final, right? So that could be why. And so then the 14.8 is the amount of error. So let's do another one. Calculate the percent error and the percent yield for the following. So our percent error, 93.5 minus 100. Divided by 100, but then times by 100. So you get negative 6.5%, but you can put that to a positive value, like I said, since it's an absolute. And then for our percent yield, 93.5 divided by 100 times by 100. So 93.5% yield. Now, the percent error, like I said, it should be a positive value, so let's take out that negative. It's an absolute. There we go. Now, when we look at them, theoretically, if you kind of think about it, unless it's over 100%, it's a little bit different. But both of these numbers should add up to 100, right? Because one of them is telling us how much wrong we were, and the other is telling us how much right we were, out of 100, right? So you can kind of look at that and see. The only thing that's weird is in that previous one, where it was over 100, okay, how much over 100 was it? About 15% over. Well, that's about our percent error, right? So, yeah. Okay, so that's all for the